Hey everyone, my name is Monique Mazerl and I'm a fourth year nursing student working with the University of New Brunswick in St. John to create some peer-led tutorials or webinars based on medication math. So today we're going to be doing IV multi-step calculations, which is the most complex of all the webinars that we have done. And when I say multi-step calculations, what this means is that there are multiple steps that you have to take within your question to get to the right answer. So there are multiple calculations that you have to do in order to get what you're looking for. So the objectives for today are to recognize what is being asked for within a multi-step calculation, as well as to convert and calculate properly, which is what you need to do for all medication math. So let's jump right into our first question. We have an order for diltiazem, a 20 milligram IV bolus, followed by a continual infusion of 15 milligrams per hour, and we need to titrate to keep the heart rate below 110 beats per minute. So the drug is supplied as 100 milligrams in 2 mils, and it also has a pre-mixed bag infusion of 125 milligrams in 125 mils. The questions that we're looking to answer are: how many mils of medication will the nurse give as an initial IV bolus, and at what rate will the nurse initiate the infusion in mils per hour? So since we're looking for the bolus in part A, we can come back up here and we see that we want to give a 20 milligram IV bolus. And we know we're not going to be using our premixed infusion because that is for the infusion. So we know that this is going to be our supplied drug, 100 milligrams in 2 mils. So that's the first thing that we have to do. We're looking for mils, so we're doing a dosage calculation here. So if we have, and we can do our D over H times Q. So we are looking for 20 milligrams over what we have. So we have 100 milligrams in 2 mils. And if we do our med math here, we know that we're going to be drawing up 0.4 mils to give our 20 milligram IV bolus. So the next question, at what rate will the nurse initiate the infusion? So we know rate is in mils per hour, so that's exactly what we're looking for. So we want to be giving 15 milligrams per hour, so let's draw this out. If we want to give 15 milligrams per hour, and we know that we have 125 milligrams, and we put that down here because we're going to cancel out our units, in 125 mils. So this way we're going to be left with mils per hour. And when we do our math here, also if you're paying close attention, you know that 125 over 125 is going to be 1. So we're going to be setting this rate at 15 mils per hour to give our 15 milligrams per hour. So that's question 1. Let's move into a little bit of a tougher one now. We have an IV infusion of nitroglycerin running at 8 mils per hour. The IV has been mixed to a concentration of 50 milligrams of nitroglycerin and 250 mils of D5W. So we want to know how many milligrams per hour the client is receiving. So that's a lot of information to look at. We know that we're running it at 8 mils per hour. We have 50 milligrams in 250 mils. So we want to know how many milligrams per hour. So what we need to do is we need to find out how many milligrams are in how many mils so that we can find out how many milligrams are within the 8 mils that are running per hour. So that's what we need to start off with. So if we're looking for milligrams per mil, then that's exactly what we can do. We know that we have 50 milligrams of nitro in a 250 mil bag of D5W. So we can simply put our milligrams over our mils. And when we calculate this out, we see that we have 0.2 milligram per mil. So now that we have this is what's going to allow us to calculate how much is going to be given per hour. Like I said, they're getting 8 mils per hour, so we need to find out how many milligrams are within 8 mils, and we needed to know it singularly, so how many milligrams within 1 mil to start that off. So let's find that. So if we have 0.2 milligrams in 1 mil, and this is running at 8 mils per hour, this is what we have to do. We're going to cancel out our units. We're going to be left with milligrams per hour. And this patient is going to be receiving 1.6 milligrams of nitroglycerin per hour. So to calculate this, we had to do this first step in order to get the second step. It's just about breaking it down when something's a little bit larger. So when we had the 50 milligrams in the 250 ml bag, you just have to break that down in order to find the next step. So this is actually the last question. So we have fentanyl continuous IV infusion going at 100 micrograms per hour. We need to titrate it as needed. And our supply is 1 milligram in 100 mils of normal saline. So we want to know at what rate in mils per hour will the drip infuse. So right off the hop, we can see that we have 100 micrograms per hour and our supply is in milligrams. So we need to do something about that. We need to convert. So that's our very first step that we're going to do. So we want to know how many micrograms are within this 100 mils. So we have 1 milligram, and we know that within 1 milligram, we have 1,000 micrograms. So that means we have 1,000 micrograms in the 100 mils of normal saline. And if we wanted to break that down a little bit further, we most certainly could, because we're going to find out in mils per hour, we have how many micrograms per hour. So if we wanted to find out how many micrograms there are per mil, we would just take our 1,000 micrograms divided by our 100 mils. We would know that there are 10 micrograms per mil. Okay, so we have a couple things here now. We know how many micrograms are within the bag. We know how many are within each mil. So let's go to our second step, which is looking at the rate in mils per hour. So we want to give 100 micrograms per hour. So if we know that within 1 mil, there are 10 micrograms, we want to cancel out our units. So we were looking for mils per hour. We want these to cancel out. And if we do this math, we find out that we're going to be setting our rate at 10 mils per hour. Because we know how much is given per mil. It makes sense if you do the math out. 10 divided into 100 is 10. So with multi-step calculations, the most important thing that you can do is just take a step back, look at your units that you have, look at the units that you're looking for, and you just have to break down the question. So if it's complex and you need to find out how many milligrams are in each mil, then that's what you have to do. It's just taking that step back to assess the question and figure out what you need from it.